Okay, today we're looking at section 2.5, equivalent statements. How do we determine if two statements are equivalent? Two statements P and Q are logically equivalent when P if and only if Q is a valid argument, or when the last column of the truth table consists of only true values. When a logical statement is always true, it is known as a tautology. To determine whether two statements P and Q are logically equivalent, construct a truth table for P if and only if Q and determine whether it is valid. If the last column is all true, the argument is a tautology, it is valid, and P is logically equivalent to Q. Otherwise, P is not logically equivalent to Q. So we're going to create a truth table to determine whether the following compound statements are logically equivalent. So we have P, true, true, false, false. Q would be true, false, true, false. Not P would be false, false, true, true. Now we're looking at a conditional, and we're looking at if P, then Q. The only time this is false is when the first one is false, or when the first one is true and the second one is false, which is true, false. So this is false here, true, true, and true. So now let's look at Q if Q is in not P. So we have not P here, and we have Q here. So I'm looking for a true. Hold on. Okay, so we have a typo. This is supposed to be not Q, not Q. So I need a not Q, which will be false, true, false, true. Okay, so now I have not Q, if not Q, then not P. So is there any time when not Q is true that not P is false? Yes, right here. Every other place it is, so it's true. So you see this and this match, so they are equivalent, and this is the symbol we use for equivalence. Equal, and then a squiggly line above it, a tilde. Okay, let's see if this one works. All right, so we have P, true, true, false, false. Q, true, false, true, false. Not Q, false, true, false, true. And then I have if P, then Q, which would be the same as above. True, false, true, true. How about P or not Q? So when one of them's true, it's true. So P is true for the first two. Not Q is true down here. And they're both false here. these are not the same, so this is not equivalent. So let's look at the converse, inverse, and contrapositive of a conditional statement. And we start with the simple conditional statement, if P then Q. The converse is if Q then P, and it's simply formed by interchanging the hypothesis and the conclusion. And it is logically equivalent to the inverse. The inverse is if not P, then not Q, and is formed by negating both the hypotheses. Inverse is logically equivalent to the converse. The contrapositive is if not Q, then not P, and is formed by interchanging and negating both the hypothesis and the conclusion. The contrapositive is logically equivalent to the conditional. So let's see how this works. Well, here we have it symbolically, which may be very helpful. The truth table below shows how variations are presented symbolically. So we have our conditional right here. We have our contrapositive, our converse, and our inverse. So now let's look at this. So if we use a statement where P is Elvis Presley wore capes and Q is some superheroes wear capes, write the following. Write the conditional statement. If P, then Q in words. So if Elvis Presley wore capes, then some superheroes wear capes. If the first statement P, then Q. Now we want to write the converse statement, which is if Q, then P. If some superheroes wear capes, then Elvis Presley wore capes. And now we'll look at the inverse statement where we're just taking the negation of both. So if Elvis Presley did not wear capes, then, and we're looking for the negation of some, and if you recall, that is none or no, and no superheroes wear capes. In the contrapositive, we go not Q, so the negation of some superheroes wear capes is if no superheroes wear capes, then Elvis Presley did not wear capes. Okay, so next up, we're looking at use the conditional statement if Dora is an explorer, then Boots is a monkey to identify the following. Write the hypothesis and label its P. Well, the hypothesis is the first statement. P. Dora is an explorer. Remember, this is if P, then Q. So Q would be Boots is a monkey. Now, identify the following statement as a converse, inverse, or contrapositive. Well, let's look at this. If Dora is not an explorer, so that's not P, then Boots is not a monkey, so that's not Q. And which one is not P, not Q? It's the inverse. So this would be the inverse. Okay, next. Identify the following statement as converse, inverse, or contrapositive. If Boots is a monkey, well, that's Q. Then Dora is a explorer, and that's P. All we did was switch the statements. So this is the converse. And which statement is logically equivalent to the inverse? That's the converse. The two verses are logically equivalent. Inverse and converse are logically equivalent. Let's see. See here and here. And conditional and contrapositive are logically equivalent. Okay. And lastly, assume the conditional statement if P then Q. If my friend lives in San Francisco, then my friend does not live in California. We're going to assume it is false. And use it to answer the following questions. So we want the converse. Okay. So we're looking at the converse, which is I'm getting old. My memory is Q, if Q, then P. So I'm looking for if Q, then P. So I want to write this as if my friend does not live in California, then my friend lives in San Francisco. Now, have to be careful here because you're looking at this statement. Is it true? Well, it is, right? It doesn't seem true because if you live in San Francisco, you got to live in California, but we're going by this being false. And the converse is not equivalent to the conditional. So if the conditional is true, if the conditional is false, that's what we're told, then this is true. Okay, then the inverse of the statement inverse, which is, let's go back, not P, then not Q. We're looking at not P, then not Q. So if my friend does not live in San Francisco, if my friend does not live in San Francisco, then my friend lives in California. So we're looking at not P, then not Q, not P. Did I do these backwards? Inverse is not P, then Q. Converse is Q, then P. No, that's right. Hold on. This is, okay, yeah, that's California. So, if you remember, the inverse and converse are equivalent. The verses are equivalent. So if the converse is true, the inverse is true. And next is the contrapositive, which is, again, let's look. Contrapositive, not P, then not Q. If not P, then not Q. So, if my friend does not live in San Francisco, then my friend lives in California. These can get confusing, especially when you're doing words. So that finishes up section 2.5.